Now that we've talked about proportional relationships and proportions and solving proportions, we're going to be spending the rest of this chapter basically talking about how to apply proportions and use proportions to solve real life situations. So in this video, we're going to be talking about scale drawings and models. And a scale drawing or a scale model is basically any drawing or model used to represent objects that are too large or too small to be represented at actual size. And when we do that, we need a way to translate measurements from our drawing or our model to the actual object itself. So to do that, we use a scale, and a scale is a ratio that compares the measurements on a drawing or a model to the measurements on the actual object. So here are some examples of some scale drawings. I have some plans for a space shuttle, some house plans or blueprints, some cartoon drawings here, when one was enlarged, and then of course a map is probably the most common version of a scale drawing, where we can find distances in real life using a scaled down version of the real thing. And then here are some scale models. These are 3D objects that represent actual objects that are much larger or much smaller than the representation. So I've got a model of a house, there's a scale model of an airplane, some model cars that are drawn at different scales. Of course, a globe would be a scale model of the entire Earth, and then another model airplane there. So back to that idea of a scale, and a scale is a ratio that compares the model measurement to the actual measurement. And then what I have shown here are the 3 different ways that we can show that ratio. Sometimes you'll see it written where the model measurement equals an actual measurement. We use a colon. That's one way to write a ratio, model measurement to actual measurement, or it can be written in the familiar fraction form, where the model measurement is in the numerator and the actual measurement in the denominator. Then below I've got some examples where you might see 1 inch represents 3 feet, so we might see 1 inch equals 3 feet, 1 inch to 3 feet, or 1 inch over 3 feet. 3 different ways to write that same scale. Or 1 centimeter equals 2 millimeters, 1 centimeter to 2 millimeters, 1 centimeter over 2 millimeters. Or maybe on a map scale, we would see 1 inch equals 50 miles, or 1 inch to 50 miles, or 1 inch over 50 miles. So those are our scales. So how do we determine what the scale is when we're given some information? So it says the pillars of the World War II Memorial in Washington, D.C. are 17 feet tall. A scale model of the memorial has pillars that are only 5 inches tall. What is the scale of the model? So how does the measurements on the model compare to the actual measurements of the pillars in the memorial? So what I did was I wrote a ratio that compared the actual to the model lengths. The model length is 5 inches, which corresponds to the actual length of 17 feet. So what we have here is a proportion. We can set that equal to our scale. So 1 inch would represent how many feet? If 5 inches is 17 feet, 1 inch would be how many feet? So this is almost like finding a unit rate. So our scale is kind of like a unit rate, where 1 unit on the model or the drawing represents so many units on the actual object. So we would solve this just like we would solve a proportion, but they're much easier to do because we've always got 1 unit in the numerator. So 5 divided by 5 is going to give us 1. So 17 divided by 5 is going to tell me what 1 inch represents. So when you take 17 divided by 5, you get 3.4. So the scale of our model would be 1 inch equals 3.4 feet. So every inch on the model is equivalent to 3.4 feet on the actual object. Another example, the length of a model of a bridge is 16 inches. The actual length of the bridge is 50 yards. What is the scale of the model? So again, I used the information that I knew from the model and the actual. The bridge is 16 inches long on the model, and it's 50 yards long in reality. So I'm going to set that equal to my scale, where 1 inch represents how many yards. If 16 inches is 50 yards, 1 inch would be how many yards? So again, dividing by 16 would tell me how many yards 1 inch is. So if you take 50 divided by 16, you get 3.125. So the scale in this case is 1 inch equals 3.125 yards. And that's just one way to write it. Again, we could write this scale in the other two ways using the colon or in fraction form. I just chose to use the equal sign there for that. So that's scale. And now we have something called scale factor. It's another way to compare the measurements on a model or a drawing to the actual object. We can use scale or we can use scale factor. And scale factor is slightly different than scale because scale factor is the scale, but it's written using the same units of measure. You'll notice that in the scales that we talked about previously, they use different units of measure, inches and feet, or inches and miles, centimeters and millimeters. They were two different units of measure. Well, when we convert these to be the same unit of measure, we then create the scale factor. So I give an example here of converting a scale to a scale factor. So for example, if 1 inch equals 2 feet, if that's our scale, what I did was I rewrote that in fraction form. 1 inch is 2 feet. And then what I did was I converted these measurements so that they were the same units of measure. I converted the feet to inches since 12 inches is in a foot, 2 times 12 is 24. So I could also say that 1 inch represents 24 inches. So now the units are the same. So essentially these units go away because I don't need them anymore. If the units are the same, they're really irrelevant. So then my scale factor is 1 to 24, meaning that the actual object is 24 times bigger than the model. So any measurement on the actual object is going to be 24 times bigger than any measurement on that same measurement on the model or the drawing. So scale factor is kind of a more useful way to compare the measurements because it's independent of any type of units of measure. So that's what makes scale factor nice to use. So let's take a look at an example here of converting a scale to a scale factor. It says on a model of an airplane, the scale is 1 centimeter equals 3.2 meters. What is the scale factor? So again, if I write this in fraction form, 1 centimeter is 3.2 meters. So I am going to convert these to the same unit of measure. So 100 centimeters is 1 meter. So 3.2 meters would be 320 centimeters. So 1 centimeter is equivalent to 320 centimeters. So essentially these units go away. I don't need them anymore. So my scale factor is 1 to 320, meaning that the actual airplane is 320 times bigger than the model of the airplane. So just a tip, when we are converting scales to scale factors, we're going to always convert to the smaller unit. Always convert to the smaller unit. So in this first example, we converted to inches because inches is smaller than feet. In this example, we converted to centimeters because centimeters was smaller than meters. That's always going to give you a better scale factor, a scale factor that you don't have to do any additional adjusting on. So how do we apply this to solve actual problems involving scales, or how do we use a scale or a scale factor? A map of a natural history museum shows that the dinosaur exhibit room is 7.25 inches wide. If the scale on the map is 1 inch equals 8 feet, what is the width of the actual exhibit room? So here's a prime example of using these proportions. This is a proportional relationship. I know my scale is 1 inch is 8 feet. And that's going to be equivalent to what I know about the History Museum. Now, I know that on the map, the dinosaur exhibit room is 7.25 inches. And that's going to be how many feet? So here I've set up this proportion using my scale as one ratio and what I know about the objects in the other ratio. Now again, I can solve this basically any way. That 1 in the numerator really makes this pretty much easy to solve this proportion. I can use horizontal, vertical, or cross products. Either way, I'm going to have to take 8 times 7.25 to solve this. So if I take 8 times 7.25, I get 58. So the dinosaur exhibit room the width is 58 feet using a proportion to solve that. So applying proportions to scale drawings and scale models using scale and scale factor.